Hi, everybody. Thanks for coming today. My name is Greg Herlein, and David and I would like today to talk to you a little bit about our experiences in the last year of what we call impedance matching legacy applications to using Prometheus. So first of all, a little bit about our background. We've both been at Cisco for about 5 years. Prior to that, we were both at Rackspace together. Before that, we were both at Technicolor for a long time together. So we have a long history. We basically took our division at Technicolor into the cloud, and it inspired us so much we wanted to go help build the cloud, which is why we went to Rackspace. And when we came to Cisco, we were hired into Cisco to build a cloud-native video application. So we're cloud guys through and through. And one of the things that I would like to touch on is when you think about Cisco, you probably think something like this, routing and switching, and what really outside of the iOS firmware that runs in a switch, what kind of software does Cisco do? And that's where you might be surprised. We actually have a tremendous amount of cloud-based software even, but a very, very large cloud footprint. And not only that, but we're helping customers build cloud. And so often people say there is no cloud, it's just someone else's computer. And so that's the world that we often live in. 3 years ago, we shifted to moving into the department we're in now, which is a Cisco customer experience, and came there to really move all of our technology into the cloud. But before that, we were working in Cisco's cloud group, directly building cloud technology. So we come at this from a very cloud background, kind of backing into the traditional Cisco world, which does extend all the way down into routers and switches. So a little bit about the problem statement we want to talk about today. About a year ago, we got involved in a major customer in Japan that is building out what they're calling a fully virtual 5G ready mobile network. And so it's from scratch, from the ground up, 5G mobile play. And it's literally everything in it is as virtualized as it can be, including the radios. So even the radios are software defined networking. All the software is all running on virtual machines. It's all running on Cisco's OpenStack. And so the challenge that we brought in, we were asked to come in and consult to help them provide really more cloud native monitoring. So how would you do that? How would you take and monitor a modern 5G mobile network, but do it with modern cloud tools? So what kind of cloud tool would we want to use to start with? We're huge Prometheus fans. Prometheus is cloud native. It was built from the ground up to support and operate in Kubernetes, where the elements, the network elements, can go away. I mean, we all know if you use a container or even use a VM, it can go poof, and then you don't have it. And so a lot of the older legacy monitoring systems just don't tolerate that very well. And so as we came along on this journey of trying to use Prometheus, we ran into a bunch of what we'll call impedance matching, because we're engineers. And that's the challenge of if you're in an all-cloud environment where you're probably running your software in at least in some kind of a cloud orchestration system, but probably in Kubernetes these days. Everybody that's here is probably at least doing something in Kubernetes. Then your problem space is a lot easier because the Kubernetes will take care of things for you. Your cloud orchestration system will take care of a lot of things for you. The cloud will take care of a lot of things. You're in AWS and you set an autoscaling group and you lose a VM, you can autoscale that baby right back up. And so a lot of the things that you need to worry about, they self-heal on their own. But if you are the cloud provider, if you're providing everything from the wires through the routing and switching up through the virtual layer, all the way up into the software layer, and you need to monitor all that, and you want to use Prometheus, then you run into a certain set of problems. And so what I'd like to do is have my friend and colleague David step up and walk you through a particular section of that and some proposals that we have to fix it. David?
Hello. Prometheus is not that old. It's probably been around since 2012 at the end, so it's about 6 or 7 years old. And it really only reached maturity within the last 3 or 4 years. So unless you've written software within the last 3 or 4 years, it's probably considered legacy. So there have been a few other monitoring talks at Spirit this year, and they talk about how to monitor your application today, if you're starting a new application today. And what I want to say is you should follow all of that advice. Right? You should implement a metrics interface for Prometheus to scrape directly into your application. You should also use tracing. You should use structured logging. So follow all of that advice. But there's a chance that you will have to integrate with an existing piece of software that does not support Prometheus. So legacy applications can emit monitoring data in many different formats. Before the days of Prometheus, there was not really a vendor-neutral monitoring API interface, right? So everyone kind of invented their own. So a lot of software components have their own APIs that you have to go query through to pick out statistics and metrics, right? So we're going to talk about adapting that to Prometheus. SNMP notifications. So before the days of HTTP webhooks to report on alerts, there was a technology called SNMP. And SNMP allowed you to emit an alert or a trapper notification that would tell another system that something is wrong. So that UDP-based packet would contain a bunch of key values on the error condition and the parameters that you would need to debug. Right? So we'll talk about hooking SNMP notifications up to Prometheus. A lot of applications had APIs that would show the faults or alerts that are active in those applications, right? We have other sources are directly from the CLI. So if you log into an old switch or something, or even a Linux box, there may not be any way that you can pull statistics out unless you actually SSH to the box and run some commands. So you'll have to connect and parse that and then convert that to Prometheus. There's network syslog. So before the days of FluentD and Elastic Beats, there's log shippers. A lot of older devices are not capable of running those programs, right? So a lot of those you send network syslogs. And then there's finally SNMP agents. So before the days of modern interfaces like the Prometheus metrics interface, you would have to You'd have to make an SNMP protocol request to get statistics out. So we can fetch those statistics and then change them into Prometheus formats, right? So a lot of this stuff applies to hardware, and a lot of us are very used to working in the cloud, right? So I guarantee you almost every single server, every switch that your cloud is built upon communicates in many of these ways. All right, so to understand this talk, you have to know how Prometheus works. So I'm going to give it to you in 60 seconds. So you have a metrics target. In Prometheus, the metrics target is an HTTP interface that you can hit to pull metrics out. Metrics are numerical numbers. Prometheus server will scrape those metrics on a periodic loop, and then it will evaluate some alert definitions against those metrics. As soon as thresholds are violated, Prometheus will emit alerts and send those alerts to the alert manager. Alert manager may receive many different alerts for the same condition, for the same issue, and it will deduplicate them and notify other systems, such as PagerDuty, Slack, or webhook to your ticketing system. All right, this is what metrics looks like. When you hit a metrics endpoint in Prometheus, you get a list of metrics, which are in ASCII form, which is very readable. There's a metric name, and then in between the curly braces, there are labels. So area equals heap host, and then there's the value of the metric. So when you write your Prometheus query language to come up with alert definitions, you are often filtering on an area or a label, right? Here's an alert definition. This says, here's a description. If the Java heap is over 80%, then okay. So if this expression is evaluated, then an alert is sent with this description and this summary. So this expression says, if the amount of JVM memory used divided by the total amount of memory is greater than 80% for 15 minutes, then emit an alert with the label critical and severity, with a severity critical, and with the description in the summary. This is the alert that actually goes from Prometheus server to alert manager. So this is just a JSON object again, and it's got labels and annotations, starts at, ends at, and a link to more debugging. So labels and annotations are both key value pairs. So you can put any key name, any value name. But the difference is that your unique set of labels, if you sort that in order and then you take a hash of it, then that gives a unique fingerprint. And if subsequent alerts with the same unique fingerprint occur, then Alert Manager knows to group them together into a single alert and subsequent notification. All right, so now we went over how Prometheus works, and clearly there are two different integration points. One is you can integrate at the metrics level here. Second is you can integrate at the alerts level, right? By sending alerts directly to Alert Manager. So by default, you should always default to integrating at the metrics level. Because if you are integrating at the alerts level, then you're not collecting those metrics for future debugging, right? So if your application only can emit alerts and not metrics, then by the time you get an alert, it's too late, right? And because Prometheus actually has functionality where you can project the statistics over time. You can project where a number or a threshold will land, like disk will be full in 4 days, right? And an alert on that. Also, when you get an alert, it's great to go back to historical metrics to help you debug. All right. Metrics level exporters. Okay, so this is the standard way to integrate something with Prometheus is to integrate at the metrics level. So let's say you have a custom numerical API for your application. So the typical way of integrating with Prometheus is to write a custom metrics exporter that on the back end speaks the API of the metrics target, and then this metrics exporter then presents a native Prometheus metrics endpoint, which the Prometheus server can scrape, right? So the arrows going down are the data flow in the system. However, Prometheus is a pull system, so Prometheus will pull the metrics exporter. Exporter will pull from the metrics target. So again, all the arrows are data flow. All right, here's another type. CLI over SSH. This is what I was talking about earlier, where sometimes the only way to get metrics out of something is to SSH in and run commands like ifconfig, right? So here's a pattern that my team uses, which is we have a CLI over SSH metrics exporter. And it is actually not one component, but two, right? So the first part is a custom collector. The custom collector is kicked off by a supervisor process. You can use cron. We use supervisor D. It collects the data over SSH expect. And it parses the data, writing the results as text files. So the second part of our system is the Prometheus node exporter, which is a very common component that almost everyone deploys on any Linux box to pull base metrics off. And this exporter can directly read the text files that are created by our text file collector. And then it exposes those text files over HTTP on a metrics endpoint, which Prometheus then scrapes. Here's another type of data that we get into our system. So sometimes we want to create metrics off of syslogs so that we can define Prometheus alerts on them. So in this case, we use an open source component called Grok Exporter. And what Grok Exporter does is it does pattern matches, Grok pattern matches, on syslog lines, and then turns them into metrics, which it exposes over a metrics endpoint, right? So we actually got to enhance that, and our merge request was accepted. So we enhanced it so that it can accept webhooks, right? So what we do is network syslog comes in, we send it to Logstash, we enable the Logstash syslog input, which then queues up the syslogs and structures them. Then Logstash sends the structured log records to the Grok exporter, which then presents a metrics interface, which Prometheus scrapes. And then that's how we get in the system, and then alerts happen later. SNMP agent. So an SNMP agent is, before the days of HTTP requests, to get statistic data, you could make SNMP walks or SNMP gets, which are all SNMP protocol requests. So you would SNMP get an SNMP agent. You can SNMP get data from an SNMP agent, and there's an SNMP exporter that is open source that we use. So we can configure the exporter to say, hey, fetch these properties, these objects from the SNMP agent, expose them with a metrics interface, and then Prometheus scrapes it. All right, now we've covered all the metrics level exporters. And if your application does not support metrics, then you have, and it only supports alerts, like fault conditions, then you have to integrate directly with Alert Manager. So we call these alert level exporters, right? And this is not very common in, actually, we found it to be very common with the software that we work with, but it's not a common pattern in the open source community. Most people expect you to start with metrics, right? But if you have a piece of hardware like a server or a switch, often there's a separate specialized processor called the BMC, the Baseboard Management Controller. And what that is a separate computer that will monitor the main hardware, right? And that is like an embedded computer that you cannot run run much software on it. But most of those things will emit SNMP traps for notifications. All right, so, okay, no, I'm sorry. Why don't I skip to that? Okay, we'll emit SNMP traps for notifications. So so we have a pipeline that we set up. So SNMP trap emitter sends a trap to SNMP trapd, which is like the de facto standard for receiving traps. We have SNMP trapd log those traps to standard output, where filebeat reads from standard input, structures the log message, sends it to Logstash beats input, and then which then webhooks the contents of that SNMP trap as a log message to a custom component that we designed that will transform SNMP traps to Prometheus alerts, right? So so we take a trap, out goes a Prometheus alert to Alert Manager, where Alert Manager then takes care of consolidating those alerts and sending notifications. All right. I accidentally skipped forward to a slide, but here's another pattern that we've seen very common, which is a lot of newer applications, but yet legacy and before Prometheus, will have their own APIs for getting the list of alerts, right? Like, so I could curl against an API and get a list of, fault conditions that are existing in that system. And what we do is we write a faults level alerts exporter that will query this the API target and then transform those into alerts and send them straight to Alert Manager, right? And this has to happen periodically. All right, challenges. So we use Alert Manager a lot. We run multiple replicas of almost every component in our Kubernetes cluster. And we do the same with Alert Manager. And Alert Manager was kind of designed for a different use case than what we need. So Alert Manager was designed for, in startups that I've been in, Alert Manager is just used for notifications. Like as soon as an alert happens, it goes to PagerDuty, and then someone wakes up and fixes the alert. There's no ticket. Usually it bypasses the ticketing system, right? But in our system, when we work with our 5G vendor, there are actually lots of, when we work with our 5G customer, there are lots of vendors in the system, and every single vendor has multiple subsystems, right? So we actually have to go from Alert Manager straight into a ticketing system, right? And then as alerts happen, as they open or as they resolve, we have to close things. We have to open things in the ticketing system. We have to close things as well. So we have much stricter requirements on consistency. Every ticket that is open should be closed also by our system, right? Whereas most people, if you're a startup, you're using this and you just want the alert so you can go fix it and it disappears. And you don't need it to tie specifically to a ticket. So we had to make Alert Manager a lot more consistent. So Alert Manager, the promise of Alert Manager with the CAP theorem is that it's available and can handle partitions. And things that would surprise you that you don't expect is that it only synchronizes a notification log, that is webhooks, to other systems. Let's say you're webhooking to Slack. It's trying to deduplicate the notifications. Then there's, it also will synchronize the silences of notifications. So if you want to silence something, a notification for like the next couple of days while you're working on it, you can do that, and it'll sync those. But the thing is, even in this AP system, once a message is gossiped, is never re-gossiped. So if you add additional replicas of Alert Manager, it'll result in those new replicas having completely empty state. So that's a problem for us. All right. The third thing that Alert Manager HA does not cover is it does not cover alert state. So Alert Manager alert state is the in-memory running status of an alert. So as the Alert Manager receives multiple alerts with the same fingerprint, it merges a single copy of that alert in memory, like basically extending the end times, and uses that one copy to send notifications for, right? So, all right. So issues, right? So if you have an Alert Manager cluster and you reboot one of the Alert Managers, then that Alert Manager loses all state. And if that Alert Manager is rebooted after an alert notification is sent, which opens a ticket, and then the AM is rebooted, then it's got no state to clear that ticket, right? To resolve that notification. All right. So also, a client that sends to Alert Manager must send to every single Alert Manager in a cluster. If that client sends to only one Alert Manager in a cluster of Alert Managers, then only one of those Alert Managers has the proper state to open and to send a webhook, to send an opening or closing resolved webhook. And what this means is that you can't really put an Alert Manager cluster behind a load balancer, which is kind of a typical Kubernetes pattern, right? And we also have our Alert Managers reset a lot. Like we restart them all the time. Chaos Cube kills them every few hours. Every time we do a rolling deployment of Alert Manager, everything is cleared. All right, another set of issues. Yes, so I talked about the ticketing system. If AM resets a state, the ticketing system never, AM loses the ability to send a resolved event or notification to the ticketing system. All right, so how do we solve this? What we did is we actually enhanced Alert Manager to clustered Alert Managers to communicate through an etcd distributed database, so that upon startup, all the Alert Managers will load all the alert state from etcd. Upon read and write in memory of updates of alert state, it'll also write to etcd. And it only does this as as a best effort. So it remains an AP system. So there's no dependency on the consistency part. So if etcd goes down, then we can, then alert managers, all the alert managers work as they always have, independently. As soon as etcd comes up, then they all sync together. All right, so we had to fork this because due to the different requirements of, I guess, use cases, the open source community wanted to keep their code a little bit more simple, right? So because they're not integrating with ticketing systems, so they don't need that consistency. So our pull request does not merge, so we had to fork it, and that's the location. All right, so I'm going to demo this for you. All right. Okay, so the first thing I'm going to show you is standard alert manager. Okay, so I'm going to run Docker Compose. I'm going to start etcd, one instance of etcd, two instances of alert manager. On the second screen, I'm going to start an etcd watch so we can see the reads and writes to etcd. On this lower left here, I'm going to start a AM watch tool, which will every second query the alert state on the first alert manager. And then on the second thing, I'm going to query the state of the second alert manager every single second. Okay, so what I'm going to do is send the first alert manager a couple alerts. So I sent 3 alerts to the first alert manager. All right, you can see the second alert manager didn't receive that state. So if I send an alert to the second alert manager, see it added that random alert right there? And then if I stop the first alert manager, you can see this state will disappear. And then if I restart it, the first alert manager just lost all of its state. Right. Okay, so I'm going to repeat this demo real quick with the etcd-backed consistent store. All right, so here's etcd. So I'm going to Docker Compose up. Okay, hold on. This is just cached. Docker Compose up the etcd alert managers. Okay, now we have an empty state. So now I'm going to send an alert to the first alert manager, and the second alert manager will get the same alert. All right, so you saw first alert manager receive it first, and then etcd received a put, and then second alert manager received the same alert from etcd. Right? So I'm going to send a couple to the first one, and then I can send to the second one. Right? Both of them have the same state. So what we can do is I'm going to stop one of these. I'm going to stop the first alert manager. And remember, in the memory implementation, it will have a clear state. But when I start the alert manager here, it will resync the state from etcd, and both alert managers will have the same state. Just waiting for it. Come on. All right. The demo gods were with us. So that's the end of the presentation. You want to say anything?
Yeah, so we're going to be hanging out at the Cisco booth. It doesn't have a big Cisco logo for some inexplicable reason. It says CX, but David and I will be hanging out there if anybody wants to ask us any detailed questions. I don't know if we have time now to take any questions.
Do we have time? Actually, we
7
have.
minutes.
So, would you like to answer a few questions from the audience?
Yeah, we'd be happy to.
Okay, so the first question is, did you find or implemented some good template for the alerts messages to make them clear and readable, in particular for Slack?
We have been using the standard Slack templates. Mostly what we do is we receive a notification and then we click through. And it takes us right to the alert manager page for that alert, where we can then click through to Prometheus and do further debugging.
Okay. And the next question is, does Alert Manager support a custom alert schema? Let's say that I have alerts coming from some third-party tools in different format. How can I integrate that into Alert Manager? How can I deal with duplicates using the single component?
Yeah, so you will have to write a custom component to convert from whatever custom system that is into two alert manager alerts. But what your component does is it must repeatedly send alerts to alert manager, and alert manager is the one that does the deduplication when it sends the notifications to Slack or your ticketing system or webhook.
Yeah, to further answer that, really that's what the magic is. This whole system, we gave it the very unimaginative name. I gave it the incredibly unimaginative name of observability framework because we're trying to give increased observability into this mobile network that we were building for. The interfaces that we picked were the two that David talked about. It's basically the metric scraping endpoint and the alert manager input. So if you've got a third party, that's basically what all those components that he covered were, components that go from some kind of proprietary or older technology into a standard alert manager format. And we're in the process of open sourcing those. So we didn't really want to highlight those so much because we haven't open sourced them. We have a long process that we have to go through like any big corporation. But we're definitely, even if we can't open source everything, we'll be open sourcing. We'll be trying to extract out some of the into libraries. A lot of this is in Python, a lot of it's in Golang, but to be able to give people a kind of a head start on doing exactly that. The good thing is the webhook interface, the interface into Alert Manager is pretty straightforward. It's a JSON blob. You do an HTTP post. It's pretty straightforward. It isn't rocket science. I'm sure all of you can cobble that together in your favorite language in 15 minutes, but we're hoping to provide some libraries to make that a little easier.
Okay, and the last question was about Prometheus in standalone mode. So you run Prometheus on top of Kubernetes, but it can be run in a standalone mode as well. What's your view on that? What are the benefits of running Prometheus in standalone mode and on the other hand on Kubernetes?
Yeah, Prometheus doesn't do much in terms of HA. The HA Prometheus story is to run multiple instances of Prometheus, each of them scraping all of the same metrics targets. So if they're talking about not standalone mode, they're talking about Prometheus Federation, where you can have different levels of Prometheus pulling more data from other Prometheus servers, right? So like you can make a tiered system to kind of get the redundancy in the HA that you want, but the Prometheus community has basically said that they don't want to solve that problem.
Okay.
Yeah, I don't run it in Kubernetes at home. I run it in standalone mode because for my limited use, running it in Kubernetes isn't going to give me anything. I think for a lot of implementations, that's probably similar. I think it's kind of depends on your architecture and where you're going to scrape from. You're not going to, as David said, that really the storage, the time series database is going to go to some kind of an elastic block store anyway. I mean, so running it inside of Kubernetes, is it really going to get you much? Maybe not.
Well, we do run.
We do run it inside Kubernetes in our production system.
Productions, yeah.
Absolutely, you're going to get auto restart. You're going to get health watching. You're going to get all those kinds of benefits. But from it really is dependent on your production implementation, whether running it standalone or running it in Kubernetes is more. If you're not going to if you're not already running Kubernetes, don't run. I would think about, do you really need Kubernetes just to run Prometheus or not? Is an open question. We could disagree.
Yeah, the question. I assume that the question is about federation versus one.
Yeah, maybe.
Okay.
Maybe.
Yeah.
I'm not sure. Okay, so that will be pretty much all. Thank you, Greg. Thank you, David.
Thanks.
So